So let's go get rid of those emissions as quickly as we can.
Then now, taking the environmental perspective again, what is our best option?
Well, with a our perspective is a range extender is the best option. And when you do comparisons, I like this graphic because it kind of brings home a little bit of perspective of, what are these emissions worth from a car perspective?
Yes.
We all drive cars. Not a lot of us drive trucks. So our perspective is from a passenger vehicle perspective. So from the range extender model, if you take what we've been describing today as an opportunity, you would look at a 1,500 kilowatt hour battery pack. And when you divide it into 10, you get 10 vehicles as opposed to one. This one vehicle will abate 122 megatons of CO2 per year.
Yes.
Which is a decent amount.
Yes.
However, the 10 trucks will get rid of 10 times that value. We'll get rid of 1,220 megatons of CO2 per year. And to put that in perspective, one diesel vehicle puts out the emission equivalent of about 34 vehicles, 34 cars. And so in our perspective, that one battery pack might have an opportunity when deployed through a range extender model to remove 340 passenger cars worth of CO2 emissions per one battery pack. And that's why we think it's more efficient in the end. If our goal here is to abate CO2, why are we putting electrification solutions into trucks? It's because 4.5% or 4 to 5% of the fleet accommodates for a quarter of the emissions. So let's go get rid of those emissions as quickly as we can.
Understood. Wow, that's some very interesting numbers that have come up there. So if we use the same battery pack, which we would require to replace one diesel truck, to instead implement that in vehicles with range extenders, fuel cell range extenders, then we could replace 340, or let me say the emissions equivalent of 340 passenger vehicles. That is quite a number.
And so when you look at the car perspective, one battery vehicle versus one passenger car, those one-for-one replacements, they make sense. The use case makes sense. A lot of us only drive, less than 50 kilometers a day back and forth from work. So the battery can be recharged at night. It's not an issue. Doing that with a truck that's doing work all day is a very difficult thing to do. And so when we look at trying to make that the largest impact we can in the shortest period of time, using the resources that we have that are not abundant to us, that we need to use them diligently and use them in the most efficient way possible. When it comes down to the question, battery or fuel cell, environmentally speaking, which is the best option for electric truck? Our perspective is the answer is yes.
Yes.
It's not battery or fuel cell. It's both.
It's both.
It's a smaller version of a battery pack and it's a smaller version of a fuel cell, so that both, when working synergistically together, is a more efficient use of our resources, and it's the fastest way that we can get CO2 out of the atmosphere.
Understood. So essentially, smaller battery pack with smaller fuel cell system is the fastest way.
It is.
From an environmental perspective.
There are other knock-on effects that we can unpack later on, because there's a whole series of other benefits that come with that.
Yes.
But at the end of the day, it truly is not a discussion, battery or fuel cell. That's a car discussion. It's not a heavy duty discussion.
Yeah.
When you look at heavy duty, it's both, and they both have to work together.
Well, I think the good news is that there is technology available to already go this way. If we're looking at something that's impossible, then that's a different thing. But now we see from this math that you could optimize that tenfold from a rare mineral perspective. That's something. Thank you for sharing that, Sean.
It's a very, and I understand it's a very simple view.
Yes.
But sometimes it's simple to understand the gravity of the situation that we're in, and a lot of times, keeping it simple can be the easiest solution. So in this case, it just doesn't make sense to put one battery pack into one diesel truck and try and abate the emissions from one truck if we have an opportunity to do 10 times that value. 1, 2 times, sure. 2 times, 3 times, sure. 10 times, that's an order of magnitude, and it can't be ignored. Figure out if there's a way that we do this a little bit quicker.
Yeah, I found your pictures interesting where you showed like one truck is that many equivalent trucks and vehicles. There you go. See, okay, so that means actually converting or using the range extension model will help one vehicle to replace 340 the emissions of 340 passenger vehicles. Sean, unfortunately, we have already run out of time. But the good news is that we have managed to, walk this perspective together with you. Thank you so much for sharing it. Yes, as you said at the outset, there are several perspectives to take. Nevertheless, I found this particularly interesting when you say, let's focus on what we don't have abundance of, what we really need to mize on. And I think this is something that, should be considered in my view. And hopefully we can take some motivation for this to start, to continue solving our decarbonization challenge that we have.
It's 4 to 5% of the vehicles. It's low-hanging fruit. Let's go get it.
Let's go get it.